Hey, super scientists. This week in science, we're going to start talking about heat sources. So you should have your big science book and you should be on page 225. Grab a pencil and let's go. You did get some background knowledge from the video that you just watched. So we are going to go through some of this together. What are heat sources? Engage your brain. Find the answer to the following question in this lesson and record it here. So we're going to actually find out the answer to this tomorrow, but we'll go ahead and read it now. The brakes on a car rub against the wheels to stop the car. But why are this car's brakes bright orange? I don't know. We'll find out tomorrow, I think. All right, main idea again is what the section of the most important data. Active readers look for main idea. Like we said last time, not just in reading, it's in all category contents. Sharing the warmth. Oh, so cute. Here are two common words, heat and temperature. You hear them every day, but what do they really mean? You've probably never thought of that. Active reading. As you read these 2 pages, circle the clue word or phrase that signals a detail such as example or an added fact. Let me zoom in while you follow along. Scientists use words very carefully. Some common words have special meanings in science. For example, when you use the word heat, you might mean how warm something is. In science, heat is energy that moves from warmer objects to cooler objects. That's important. It moves from warmer objects to cooler objects. So what I do in my book, you do in your book as well. The temperature of the water in these hot springs is higher than the temperature of the monkeys. I guess I didn't notice that they were in water. Heat flows from the warmer water to the monkeys. The monkeys feel warmer. So remember, heat flows from warmer objects to cooler objects. So the warmer object is the water, and the cooler object is the monkeys. Temperature is the measure of how hot or cold something is. Temperature can be measured in degrees. Water with a temperature of 32 degrees Celsius, different countries use different ways, different words to measure, but it's the actual same temperature, which is 90 degrees Fahrenheit. We use Fahrenheit, so 90 degrees is really warm water. It's hotter than water with a temperature of 12 degrees Celsius or 54 degrees. So this is what we use. So 90 degrees is pretty warm, very warm water, in fact. 54 degrees is really cold water. So if we were going to say these degrees outside, 90 degrees is like summertime, super hot. 54 degrees is, for some of you, really cold, but I think it's a nice temperature. Remember, heat is energy. When you come across words like remember, that's an important clue word there. Heat is energy. Heat always moves from an object with a higher temperature to one with a lower temperature, like we just underlined on the previous page. It goes from warmer to hotter, higher to lower. Same thing said in a different way. The red part of the metal horseshoe has a very high temperature right here. Heat moved from the fire into the red part of the horseshoe. Hotter moves to cooler. Okay. Heat can move. Well, yeah, it moves from hotter to cooler. In each picture, heat will flow from one object to another. Draw an arrow to show which way it will flow. So which way? This is a boiling pot of water. Which way is the heat moving? From the bubbles to the bottom or from the bottom to the top? From the bottom, where the heat, extra heat is on the stove, to the cooler water. What about from the fire to the marshmallow? It moves from the warmer heat to the cooler marshmallow. And from the warmer water to the cooler ice cubes. Okay. Turn up the heat. Next page. Heat moves from something warmer, here we go again, to something cooler. You rely on that every day. How? Here's just one way. Would you like to eat nothing but raw food? No, I don't like sushi. Ugh. For things to cook, they must gain heat energy. Heat moves from the blue flames to the pot. Then it moves from the pot to the stew that's inside the pot. And the heat cooks the stew. So cause and effect. We start at the hottest part and then the pot is warmer than the stew. So the pot would then warm up the cooler stew. It's like a cycle. All right, on the next page, we have a 1 and a 2. So let's read 1. This oven is used to bake food. Heat moves from the oven to the air inside the oven. Then it moves from the hot air to the food. The heat from the oven baked these cookies. Okay, well, now I want a sweet treat because the last page we saw marshmallows and now we got cookies. Some things slow the movement of heat. The woman in the picture is using oven mitts. I'm sure you've seen mom or dad use oven mitts before. The mitts slow the movement of heat so she does not get burned. So inside the oven is probably 350 degrees, which means the pan is probably 350 degrees. You cannot touch 350 degrees, it will burn your skin, which is why we would protect ourselves with oven mitts. Do the math. What food? We have a table here, types of food, and the cooking temperature. What foods are cooked at 145 degrees? $145, salmon and beef. Salmon is a type of fish. And beef. Which foods need to be cooked at a higher temperature, eggs or chicken? Eggs need to be cooked at 160, chicken is at 165. So which one's higher? Yep, the chicken. And what food is cooked at 160 degrees Fahrenheit? We just said that. 160, slide over, eggs. Okay. So that's all for today. We're going to do the rest of it tomorrow. Your takeaway today, again, warmer objects. The heat moves from warmer objects to cooler objects. And temperature measures how hot or cold something is. We will stop for today. And tomorrow we will pick back up with the rest of our little section. And we'll see you tomorrow.